Hello everyone, my name is Elif Sarayışık. I'm a freshman student in Electrical and Electronics Engineering Department in Bilkent University. Today I'm going to present my PHYS102 lab project. The name of the experiment is Wireless Power Transformation. The purpose of this experiment is to study the transmission of electric energy from a power source to an electric load wirelessly by using the method of inductive coupling. The power will be shown as the brightness of a LED, which is a circuit element for the receiver coil, and the LED will be lightened due to the electromotive force induced by the rate of change of magnetic flux over time, which is created by the transmitter coil. Prior to the beginning of the experiment, these are the required equipments. First of all, an enameled copper wire, which is a thickness 0.3 mm, a transistor, namely N2222A, a 470 ohm resistor, a LED, a power supply, a multimeter, a solder and a soldering iron, 2 crocodile cables, a tape, and a sandpaper. In the first part of the experiment, I created the transmitter and receiver coils of diameter 5 cm with the number of turns 50. In contrast to the receiver coil, which has 2 exits, transmitter coil has 2 exits with the loop after its 25th turn in order to make a connection with the transistor. I use a sandpaper to make the exits of the coils conductive. I connect the collector part of the transistor to the one of the exits of transmitter coil by melting the solder. The base part of the transistor was connected to the 470 ohm resistor and then to the other exits of the transmitter coil. The emitter part of the transistor was connected to the input side of the power supply by a crocodile cable. The loop of the transmitter coil was connected to the output side of the power supply by a crocodile cable. The 2 exits of the receiver coil were connected to the exits of LED. Finally, 2 coils were taped on the plane in order to maintain an optimum position with distance 3.5 cm. This is the final version of the circuit of the inductive coupling. Second part of the experiment, the power supply was set to 9 volts and the connection of the circuit was completed. In order to change the magnetic flux passing through the receiver coil, the tape of the receiver coil was removed and the distance between 2 coils was subsequently adjusted to 6 cm, 3.5 cm, and 1 cm in equal time intervals. At this stage, the current passing through the receiver coil was measured by using the multimeter and noted down in the table 1 in my final report. After a time, the transistor wasn't able to regulate the current passing on it, and this led magnetic flux not to be created. This is the main reason for LED was not able to be lightened after a time. Theoretical values of the current were calculated by using the formula of mutual inductance and noted down in the table 1 in my final report. It is expected that the current passing through the receiver coil will increase as the rate of the change of magnetic flux over time increases. However, the current passing through the receiver coil decreases as the distance between 2 coils increases. Estimation of the error percentages was calculated by the given formula. When the distance between the 2 coils is 1 cm, the error percentages was 23.0. For 3.5 cm, error percentage was 16.9. For 6 cm, error percentage was 68.0. The experiment caused errors for following reasons: deteriorated shape of the coils, tangles on the wires, misfunction of the transistor, measurement errors due to the multimeter, not properly connecting the crocodile cables to the circuit elements.